the day the shipyard learned to move like a factory. April 27, 1942. Richmond, California, dawn breaks cold and metallic over the flat sweep of the San Francisco Bay, and the air smells of salt, oil, and hot metal. On the long wooden shipways of Kaiser's Richmond yards, 100,000 square feet of steel wait like unfinished teeth. Men and women arrive in lines that look like veins feeding the plant, riveters with leather aprons, welders with goggles and soot-blackened faces, crane operators rubbing sleep from their eyes, and tired clerks clutching blueprints scarred with coffee rings. A foghorn moans out in the harbor, and a shipyard whistle cracks the morning, an animal call that sets them in motion. Henry J. Kaiser stands on a raised platform beside the first slip, chewing on a cigar and scanning the scene like an engineer reading a complicated clock. He's not in uniform. He never was. He wears a plain workshirt, sleeves rolled to the elbows, and his hands are stained with grease. Around him are foremen who answer to him, men like Frank Kelly, a hard-jawed supervisor who moves with a confidence that comes from having coordinated thousands of men on other construction jobs. Nearby, a slender woman named Maria Santos, a welding forewoman, taps ash into her palm and signals a crew. Her arc welders, portable, roaring boxes, spit sparks that look like tiny, controlled lightning strikes. The welding masks throw their faces into sharp ceramic silhouettes. You feel it, the impossible pressure and the stubborn hum of confidence. The War Department has issued quotas that read like demands from another planet, cargo ships enough to keep supply lines breathing, to replace those sunk by U-boats in the Atlantic and raiders in the Pacific. The Navy wants hulls yesterday. Shipyards on the East Coast mutter dismay and check rusted machines. They talk about rivets, the old method of fastening steel plate that had shaped ships for a century. Riveting is precise, slow, and experienced men are its priests. But here in Richmond, the plan is to break every consecrated rule. At the center of the turmoil sits the Liberty ship, a blunt-nosed, boxy vessel designed not for beauty but for production. She carries coal, steel, ammunition, and hope. The blueprints show straight lines, simple angles, and a hull built from dozens of pre-cut plates. Instead of craftsmen riveting each seam, Kaiser has gambled on welding, a technique for joining metal that promises speed, fewer hands in tight spaces, and the possibility of building a hull like you'd assemble a car. The gamble is that welding can be industrialized. Prefabricated sections drop into place like jigsaw pieces. Welders stitch seams in long, hot seams, and cranes move modules like blocks. On this morning, a delivery barge nudges against the piers carrying a straight spine of a ship's keel, pre-assembled upriver and barged in from another yard. The men clap hands and run, not in disorganized panic, but with a coordinated, rehearsed urgency. A gantry crane, its great hook dangling like a suspended moon, swings. The keel is lifted, swung, and lowered into the slip. Sparks fly, not from a single skilled artisan but from dozens of stations where welders work in relay. One finishes a bead, another grinds the slag, a third checks alignment with a plumb line and a carpenter's square. They shout numbers and clap signals. A foreman with a clipboard updates a chart and draws a red line, progress. A young welder named Joe Ramirez, 22, stands bent over a seam under an arc lamp. Sweat runs down his neck despite the morning chill. His faceplate is foggy. He has a calloused left hand and a trembling right hand from the night his brother was reported missing at sea. He doesn't think about the physics of shipbuilding. He thinks of the smell of burning flux, the weight of the electrode holder in his hand, the rhythm of the bead, in, out, steady, and how every inch he lays adds to a promise that a convoy will cross an ocean and return. Above them, steel scaffolding bristles like scaffolds around a cathedral. The ship's deck plates are lowered into place by a team that dances around the load, ropes and guide poles aligning the plates within tolerances that would have been miraculous a year earlier. Women move with the same determination as the men. Rivet splitters have been replaced by fitters and welders. Clerical pools have become planning cells. The yard has become a microcosm of democracy and discipline. A Dutch foreman, a Filipino crane operator, a Navy lieutenant sent from Washington to observe, and a black welder who once worked the railroad, all breathing the same salt air and following the same whistle. Kaiser paces the edge of the slip, eyes on the stopwatch a Navy liaison holds. The stopwatch is a small, merciless witness. "We can do this in weeks," he says, and the men laugh not in disbelief, but because the laugh keeps their chins up. For months, the conversation in Washington has been about how fast can we make them. Engineers have thrown around numbers like 100 days, 60 days, 30 days. But in Richmond, they have an obsession with shaving hours and tightening schedules, until the margin between possibility and impossibility becomes a working plan. A single radio crackles from a foreman's pocket. It's a Navy voice clipped. "Status on hull 3. The reply is a string of numbers and clipped phrases: keel set, modules mated, welds tested. Somewhere in that exchange is the heartbeat of a nation trying to outpace a shadow. Every ship that slides down these ways might sail with men who'd otherwise drown without cargo, food, parts, and ammunition. The first module is bolted into place and welders begin their long, searing stitch. You can almost taste the iron on the air. An arc flashes, a hiss like rain on hot steel, and a new seam becomes a seam no longer, it holds. The whistle blows a long, high note, and the men break for a moment, a fragile, shared exhale. Someone shouts, 12 hours, as if to mark an invisible rung climbed. Beneath that exhilaration lurks skepticism. Across the country, veteran shipwrights mutter about brittle fractures and structural flaws that might appear in cold Atlantic waters. Kaiser hears them, but answers with production charts and welding tests. He believes that speed itself is a weapon. If you can flood the seas with cargo ships, even skilled U-boat captains cannot sink supplies faster than factories can replace them. The audacity of the idea hums in the yard like a live wire. On this morning, the impossible is only a rumor. By nightfall, it will be a pattern. By the next week, a standard. The yard will keep breathing, and the bell of industry will toll again. But on this morning, with the foghorn and the rhythm of the welders, with Henry Kaiser watching like a man who knows he's rewriting rules, the yard feels like the precise edge where invention meets necessity. The assembly line that floated. Night fell over the Richmond shipyards with a glow that could be seen from miles away. Floodlights bathed the slips in a harsh, white brilliance, turning sparks into falling stars and shadows into silhouettes of men working against time itself. The hammering, grinding, and arc flaring never stopped. It was as if the entire yard had forgotten the concept of rest. Henry Kaiser didn't just build ships, he built rhythm. By 1942, that rhythm had a name: modular construction. Instead of assembling a ship piece by piece on the slipway, Kaiser's engineers broke the hull into vast prefabricated sections. Stern, bow, engine room, midship, each built separately, in parallel, by teams who never waited on one another. While one crew welded bulkheads, another installed piping in a section 100 yards away. Overhead cranes shuffled components like cards in a deck, slotting massive steel blocks together with astonishing precision. In the old days, a shipyard felt like a monastery, skilled craftsmen working in quiet reverence, measuring twice, cutting once, taking months to coax a hull from timber and steel. But Richmond was more like Detroit. Kaiser had studied Henry Ford's assembly lines, watched cars roll from frame to finished product in minutes, and thought, why can't ships do that? He brought in planners from the auto industry, managers from concrete dam projects, and engineers who had never seen an ocean before. They didn't know how ships were supposed to be built, and that was exactly why Kaiser hired them. Inexperience became innovation. They drew charts, timetables, process flows. They replaced bottlenecks with conveyor belts, craftsmen with teams, hammers with electric welders. And then came the welders, thousands of them, most of whom had never touched steel before the war. Housewives, students, farmers, former clerks, and retirees. They learned fast. A woman named Rosie, one of many Rosies in the yard, worked beside veterans from Pennsylvania steel mills, her hands trembling at first until they steadied into precision. The air stank of flux and ozone, and the rhythmic hiss of molten metal stitched the day together. By midsummer, Liberty ships were no longer built, they were assembled. Pre-cut panels arrived from inland factories by rail, stamped with numbers like puzzle pieces. Welders followed coded instructions, connecting seams labeled A14 to B27. Each day shaved minutes off the next. The first Liberty ship at Richmond took 244 days to build. The next, 170. Then 90. But Kaiser wasn't satisfied. He told his managers, if we can make one ship in 90 days, we can make one every 10. The men thought it was a figure of speech, until he called a meeting in July and ordered the unthinkable, a competition to build one Liberty ship faster than any in history. The project was named Robert E. Peary. On November 8, 1942, the challenge began. The keel was laid at dawn. Floodlights blazed through the night. Workers took shifts in 12-hour rotations, men relieving women, women relieving men, tools never cooling. Coffee flowed like oil and mess tents buzzed with rumor. Could it actually be done? The welding sparks painted the night sky, and even the local paper sent reporters to watch. The project had become a kind of theater, a defiant display meant for Berlin, for Tokyo, for anyone who doubted American industry's heart. Every time the whistle blew, another section dropped into place. The radio announcer called it the race against the Axis. 4 days later, 4 days and 15.5 hours to be exact, the Robert E. Peary slid into the water. Thousands of shipyard workers watched, tears streaking down soot-stained faces. Some had welded her keel and were now welding another. Henry Kaiser stood on the platform, his hat in his hands, a rare silence hanging over him. A tugboat's horn bellowed, echoing across the bay. The ship's hull was still warm to the touch. On her deck, flags snapped in the wind. From 230 days to 4, a transformation so staggering that Washington didn't quite believe it until the reports were verified. The Peary wasn't a fluke. She was proof. The system worked. And while one ship made headlines, hundreds followed. Liberty ships began sliding into the sea in an unstoppable rhythm, one every few days, then multiple per week. The assembly line had conquered the ocean. But this new speed came with a cost, one that no blueprint could anticipate, a flaw buried deep within the welded hearts of these miracle ships. The cracks beneath the Victory. Winter 1943. The Atlantic was black glass under a waning moon, broken only by the silhouettes of Liberty ships pushing through storm and darkness. Their hulls groaned as steel plates flexed under the weight of waves and cargo. Somewhere out there, beneath that shifting cold, German U-boats waited, the unseen predators of the deep. But now, for the first time, they were outnumbered. The Allies had turned steel into strategy, and Henry Kaiser's ships were the bloodstream of the war. From the ports of New York to Murmansk, convoys filled with Liberty ships steamed in endless procession. Ammunition, food, fuel, tanks, locomotives, everything the free world needed rode on their decks. Each one carried a welded plate stamped with the name of the yard that birthed her: Richmond, California; Portland, Oregon; Mobile, Alabama. But beneath the triumph, engineers began to notice something strange. Ships returning from the North Atlantic showed cracks, long, jagged fractures running through welded seams. At first they were small, spiderweb patterns across deck plates or near hatches. But as winter deepened and temperatures fell, some cracks ran the length of entire hulls. In early 1943, disaster struck. The SS Schenectady, fresh from her trials in calm Oregon waters, was sitting quietly at dock when, without warning, she split in two. The crack ran clean through her hull, right along a welded seam. Witnesses described the sound as a rifle shot magnified 1,000 times. One moment she floated proudly. The next, she lay broken, her stern and bow sagging into the river like the halves of a snapped bone. Word spread fast. Welded ships, Kaiser's ships, were breaking apart. Riveting, the old guard said, would never have failed like this. Shipwrights who'd mocked the old men and their rivets began to wonder if the shortcut had gone too far. Kaiser's engineers didn't panic. They investigated. They cut samples, tested welds, pored over blueprints. What they discovered shocked even the experts. The steel itself had turned brittle in the cold. The new, high-efficiency welding methods created stresses that traditional riveting never revealed. In freezing waters, those stresses became fractures. In Washington, bureaucrats murmured about mass-produced fragility. In London, convoys whispered rumors that Liberty ships were ships of glass. Yet even as those doubts spread, Kaiser refused to slow down. He turned the investigation into another problem to solve. Metallurgists and engineers were summoned, and new testing labs sprang up beside the yards. They discovered that the fault wasn't in welding, but in steel composition, and in how stresses traveled through welded structures. Fixes came quickly. New grades of steel, improved weld joints, crack arresters, reinforcements placed like stitches inside the ship's skin. Within months, the failures stopped. And by the time the improved Liberty ships hit the Atlantic again, the convoys had already doubled in strength. Kaiser's gamble had worked. Out of 2,700 Liberty ships, only a handful ever suffered catastrophic cracking. The vast majority weathered every ocean, every convoy, every torpedo that missed its mark. Still, Kaiser knew what the headlines never said, that innovation never comes without error. The war had forced him to compress years of testing into weeks of urgency, and yet that urgency had saved the world's supply lines. By 1944, the yards at Richmond were a living machine. The skyline shimmered with cranes and cables. The ground trembled from forklifts and hammering. Over 90,000 men and women clocked in every day, a city of builders within a city. Cafeterias ran around the clock. Nursery schools cared for welders' children. Buses ferried entire families to shifts that began and ended at all hours. Standing on the platform above slip number 3, Kaiser could see rows of ships stretching into the fog, each one bearing the proud block letters, U.S. Maritime Commission. Each one represented a few days of work and a few weeks of life for men at the front. As Liberty ships rolled down the slips into the bay, Kaiser's engineers began designing something even faster, even stronger: the Victory ships. Sleeker, more powerful, able to outrun submarines. But the principle was the same: modular construction, assembly line precision, civilian genius unleashed by necessity. The Liberty ships had proven something deeper than engineering, that democracy could outbuild dictatorship. From the steel yards of Richmond to the freezing Atlantic, from welders, torches to convoy decks, the rhythm of progress beat louder than the guns of war. Henry Kaiser would never wear a uniform, never fire a shot, but his ships carried armies, fed nations, and turned the tide of history. And when the war ended, the man once called a dreamer, even a fool, stood quietly beside the bay, watching one last Liberty ship glide into the Pacific sun. Behind him, the crane stood still for the first time in years. Before him, the ocean glittered with the ships that had saved it.